Hello everyone and welcome to AWS Database Services Selection or Decision Guide. This is one of the most important lecture of the entire course. I will go as far as saying that if you watch this lecture and pay attention, then you will most likely be able to answer all the database related questions. Most exam questions will ask you to pick the right database service or will try to confuse or trick you into choosing between similar database services. So if you go through this lecture, then hopefully you will be able to tell the differences or similarities between the services clearly. So this lecture will contain all these topics: database model, use cases, scalability, data consistency and compatibility, pricing, backup, recovery, monitoring and migration, transaction support and keynotes, availability SLA, management model and operational overhead, exam focused decision guide. So first set of parameters are database model, use cases, scalability, data consistency and compatibility. So first database is Amazon RDS, Relational Database Service. Database model is relational. Common use cases are OLTP, online transaction processing, web mobile apps, e-commerce, customer relationship management, ERP, enterprise resource planning and migrations. Scalability approach is vertical, instance based, horizontal, which is for read replicas, storage is auto and manual, and there is a RDS proxy feature. Next, high availability features. We have multi-AZ, which is synchronous standby, auto failover, snapshots, and point-in-time recovery. Data consistency is strong, asset support, and eventual, which is read repair kind of eventual consistency. Engine compatibility. So it offers all the database engines like MySQL, PostgreSQL, MariaDB, SQL Server, Oracle, and IBM DB2. Next service is Amazon Aurora. It's a relational database model. It's for high performance OLTP transaction. Use cases includes enterprise applications, SaaS, gaming, migrations. Scalability approach is vertical, instance based, and there is a serverless model also available. And serverless is not available for RDS. Then you have horizontal scaling, where it offers read replicas, auto scaling. Storage is automatic, so it will scale automatically, and there is a global database option also. High availability features, it has multi-AZ, so it has built-in multi-AZ. You can have 6 copies between 3 availability zones. There is a auto failover with less than 30 seconds, point-in-time recovery, backtrack, and global DB. Strong asset support and eventual read repair. There are only 2 options, MySQL and PostgreSQL. So this is the only thing which we have to keep in mind. So if the exam asks you something like MariaDB, SQL Server or Oracle, Aurora will not support. Next comes Amazon DynamoDB. This is a key value document kind of database model. Common use cases are high traffic web, e-commerce, gaming, tech, IoT, mobile and microservices. Scalability approach, horizontal, or it is automatic provisioned. Storage is auto. So horizontal also there are 2 types. There is auto and provision mode. It is serverless and there is on-demand mode also available, and it offers global tables. Then high availability features. It is multi-AZ. It is built-in multi-AZ support. It can span 3 AZs. There is a global tables with multi-region active replica, point-in-time recovery, and on-demand backup. So data consistency is tunable, and you can have strong consistency as well as eventual consistency. And this is a proprietary NoSQL database. Then comes DocumentDB. Database model is document, so it's something like JSON document. Most of the time, it's like you can have schema-less JSON documents. Common use cases are content management, catalogs, profiles, migrating if you want to migrate MongoDB, and generative AI. Scalability approach is vertical, instance based, horizontal, and within horizontal you have read replicas, you have elastic clusters and sharding feature. Then storage is automatic and it offers global clusters. High availability features, multi-AZ, it has built-in multi-AZ, and there are 6 copies it can span in 3 availability zone. Automatic failover, and that is less than 30 seconds. You have snapshots, point-in-time recovery, and global clusters. Data consistency, strong data consistency, which is a primary, and eventual for read repair. So read repair, like some primary will fail over, then read will be promoted to the main one, the master. Then engine compatibility, you have MongoDB API, and the version which it supports is 3.6, 4.0 and 5.0. Next, elastic cache. So it is used as in-memory cache engine. Common use case: caching, session stores, leaderboards, real-time analytics, PubSub, generative AI cache. Scalability approach: vertical, so node type, so it can vertically scale. Horizontal scalability, so you have nodes, shards, replicas, and auto scaling also. And there is a serverless mode also available, which is automatic, so you can choose either of them. High availability feature, you have multi-AZ, and there are two cache engine, Redis and Valkey. Then there is a auto failover snapshots, both for Redis and Valkey, and there is a global data store. Data consistency is eventual, and engine compatibility. So there are three software which are available as part of Elasticache. So you can choose. There's a Redis open source software, Memcached, and Valkey. These three are totally different engines, so you have to choose one of them. Next come MemoryDB, and the database model is in memory, but this is a database, and Elasticache is in memory, but it's a cache. So common use cases are microservices, real-time apps, durable cache, gaming, streaming, and generative AI. Scalability approach, vertical, so node type, so it's an online node type, and horizontal for shards. So shards is basically your partitions, like how the database is distributed in various chunks or blocks. Then read replicas. High availability feature, you have multi-AZ transaction log, which is durable. It has automatic failover, lossless. It has snapshots, and it is multi-region. Data consistency, strong, and eventual for read repair and multi-region. Engine compatibility, Redis and Valkey. Next come Amazon Neptune, which is a graph-based database model. So common use cases are social networks, recommendations, fraud detection, knowledge graphs, and generative AI. Scalability approach, vertical, where it is having instance-based vertical scaling and serverless model also available. And for horizontal scalability, you have read replicas and auto scaling. Storage is automatic, so it can expand automatically. And there is a global database option also available. High availability features, you have multi-AZ, so it is built in. You can have 6 copies spread across 3 AZs. Auto failover, snapshots, point-in-time recovery, and global database. So these are the features for high availability. Data consistency model is strong with asset compliance and eventual for read repair. Engine compatibility, so these 3 engines are available. So these are Gremlin, OpenCypher, and SparkQL. So similar to cache, these are totally different technologies. So you have to choose one of them. Next come Amazon Key Spaces, and this is a wide column database. So basically key spaces, you just remember it's a Cassandra database. So if you just remember all what you can do with Cassandra, you will be able to answer all the questions. So common use cases are if you are migrating from Cassandra, so you can straight away go to key spaces. It is used for high scale industrial applications, IoT, and gaming. Scalability approach, horizontal, so it's automatic and there is a provision mode. Storage is also automatic, and serverless, which is available on demand. High availability features, multi-AZ, which is built in, and you can have 3 replicas. Point-in-time recovery, multi-region replication, and data consistency, it is tunable, like you can fine tune it. So there are some options like local quorum and local one. Engine compatibility is Apache Cassandra, Cassandra Query Language, CQL. Next one is Amazon TimeStream, which is a time series database model. Common use cases, IoT, DevOps monitoring, industrial telemetry, and app analytics. Scalability approach, serverless, and it has some auto ingest and storage and query mode. So these are the features for serverless. You have instance based model, instance based instance also like this mode also available, which will be using InfluxDB. There is a technology or a software, so that will be like only for InfluxDB. It's instance based. Then comes high availability features. You have multi-AZ, which is built in, spread across 3 AZs, and you have live analytics and AWS backup integration. So these are the features. Data consistency is eventual. So eventually the data will be consistent. So there are two mode: strong consistency and eventual. Engine compatibility, you have SQL like, you can use SQL statement and InfluxDB API. Then next we have Amazon QLDB, Quantum Ledger Database. So it's a ledger. Ledger is basically, it will like a transaction record, and you can verify from the start of database till infinity that whether all the transactions are not corrupted or tampered with. So basically it has a hash kind of a thing, and it just it's similar to blockchain kind of technology. Then common use cases are systems of record, supply chain, finance, and audit trails. Scalability approach, it is serverless. High availability features, multi-AZ, which is built in. Data consistency, very strong. It is asset compliant and serializable as well. Engine compatibility is PartiQL. So, but QLDB, the question may come in the exam, but it's kind of end of life. Then comes Redshift. Even though it belongs to analytics services, I will just mention it because it gets very easily confused, because this is also a kind of database, but it's 100% analytics. So it's used for data warehousing. And common use cases are business intelligence, analytics, online analytical processing, log analysis, data lake querying. Scalability approach, you have vertical node types available, you have horizontal nodes also, you have concurrency scaling, and serverless model also. So you can choose one of them. So you can go with managed option or serverless. Then high availability features, you have multi-node cluster fault tolerance, snapshots, point-in-time recovery, cross-region snapshots. And data consistency is a strong, asset compliance, and engine compatibility. So you can use PostgreSQL based SQL statement to query the database. Next set of parameters are pricing, backup, recovery, monitoring, and migration. So Amazon RDS, you are charged based on instance hours, on the amount of data storage, IOPS, input outputs, and data transfer. So these 4 parameters. Backup options, you have auto and manual snapshots, point-in-time recovery for the logs, native backup, and restore also. So recovery options, you have restore from snapshot, direct restore, and point-in-time recovery to a new instance. Monitoring integrations, you have CloudWatch, performance insights, CloudTrail, events. Ease of migration, high. You need database migration service for homogeneous and medium for heterogeneous. Next come Amazon Aurora, which is charged based on instance hours, Aurora compute units, storage, IO, and backup storage. So 4 parameters, all 4 will be charged. And backup options, you have automatic and manual snapshots, point-in-time recovery is a backtrack feature, and you have continuous backup also. Recovery options, you can restore from snapshot, restore directly, point-in-time recovery, and backtrack. So same integrations, CloudWatch, performance insights, CloudTrail, and events. Then ease of migration is high. You have RDS snapshots and replica. You can migrate from that, or you can have from heterogeneous, means Aurora to Aurora, it's medium. So next come DynamoDB. So typical, you will be charged based on the request units, capacity units, storage, and the backup storage. Backup options, you have point-in-time recovery, continuous, and on-demand backup. Recovery options, restore from point-in-time recovery or backup from new table restore. Then monitoring integrations, CloudWatch, contributor insights, and CloudTrail. Ease of migration, it's medium. You can have database migration service or data pipeline for migration. Next come Amazon Document DB. You will be charged based on the instance hours, storage, IO, backup storage, and data transfer. And backup options are automatic and manual snapshots and point-in-time recovery, which is continuous point-in-time recovery. Recovery, you can restore from snapshots or point-in-time recovery to a new cluster. or you can restore directly. Then you have CloudWatch, Performance Insights, and CloudTrail as the monitoring options. Ease of migration is high if you are migrating from MongoDB, medium to other databases like document to document DB or some other version to some other version. Next come Amazon Elastic Cache. So typical pricing unit model is node hours, and based on the serverless, you will be paying Elastic Cache compute units. So if it's a serverless mode, then how much GB per hours is being transaction, how much data is getting transferred, and the how much you are storing in the backup. And the backup options are manual and auto snapshots for Redis, Valky to S3 buckets. Recovery options, you have restore from snapshots for the new cluster or direct restore. Monitoring is same. Event notification is the additional thing. And ease of migration is high if you are doing Redis import export, but still it's a high effort. Next, Amazon Memory DB. You will be charged based on the node hours and how much data is written in terms of GB, how much snapshot storage space is being used, and the data transfer. Backup options, automatic manual snapshots to S3 and multi-easy transaction log. Recovery options, restore from snapshot to new cluster and direct restore. Monitoring integrations, we have CloudWatch, CloudTrace, and event notifications. Ease of migration is high for Redis RDB import, and medium depend on many factors. Then comes Amazon Neptune, and this is charged based on instance hours, Neptune compute units, storage, IO, backup, and storage. And backup options, again, automatic manual snapshots and point-in-time recovery via this AWS backup service. Then recovery options, restore from snapshots, point-in-time recovery to new cluster or direct restore. Then monitoring integrations, you have again same, but additional, you have audit logs. Ease of migration is medium. You can have bulk loader or database migration service. Next, Amazon Keys Spaces. You will be charged based on request capacity units, storage, point-in-time recovery storage, and data transfer. Backup options, point-in-time recovery continuous. And recovery options, restore from point-in-time recovery to new table. Then monitoring of integrations, CloudWatch, and CloudTrail. Ease of migration is high from Cassandra and medium. So depends, like depending on the version and some other factors like model and all. Then comes Amazon Time Stream. So typical pricing model is depending on how much writes, how much data you write, storage, which is basically memory, and whether it's magnetic or SSD, and how much queries. So the time stream have one live analytics version also. So that will be based on how much querying is being done. Then backup options is managed via this separate service called AWS Backup. And you can have backup to snapshots also. So recovery options, recovery from backup for a new table. So it will totally restore. Monitoring integration, CloudWatch, CloudTrail, and ease of migration is medium. And you can use batch load and DMS database migration service. Then Amazon QLDB. So pricing is read, write, IOs, and journal storage and data transfer. Backup options, journal export to S3, no native backup, and restore. Recovery options, restore via journal replay, restore manual process from S3 export. Monitoring integrations, CloudWatch and CloudTrail. Ease of migration, low or lower specific ledger model, but this is a end of life. Amazon Redshift, you will be charged based on the node hours, Redshift processing unit, how much is the managed storage, any spectrum query, and concurrency scaling. Backup options, you have automatic manual snapshots to S3. Recovery, restore from snapshot, restore to new cluster or namespace or table. Monitoring integrations, you have CloudWatch, CloudTrail, and query monitoring. Ease of migration is medium. So you can have schema conversion tool, copy, and database migration service. Okay, next one is transaction support and some keynotes. So RDS, you have transaction support, you have multi-statement, multi-table, standard SQL. So it inherits ACID properties of the chosen relational engine. So it depends on the engine. So how much ACID compliance they offer. So some may have some different features depending on what engine you have selected. It could be MySQL, PostgreSQL, Oracle, IBM DB2. So it depends on that. Next comes Aurora. So again, this is same multi-statement, multi-table, and MySQL and PostgreSQL compatible SQL. And Aurora Distributed SQL (DSQL) uses optimistic concurrency control. Aurora Limitless maintains strong consistency across shards. Then Redshift, same multi-statement, multi-table. It will use standard SQL. It is primarily an analytical system, but supports standard ACID transactions for data loading and manipulation. Next, DynamoDB. It's a multi-item, multi-table within single API call, up to 100 actions. So some keynotes: strong reads cost, which is 2 times the cost of RCU of eventual reads. So this is just some facts which you have to be aware of. Transactions use optimistic concurrency. Multi-region strong consistency for global tables, which is still in preview. This is a new feature. Then key spaces. It has single item atomic operations. It has lightweight transactions for conditional updates. So some keynotes: local quorum ensures writes are durable across AZs before acknowledgement. Read consistency is tunable per request. Next, DocumentDB. It's a multi-document, multi-statement, multi-collection, multi-database, and all CRUD operations. So some keynotes: support standard MongoDB ACID compliance document, ACID compliance. Document modifications will be atomic and consistent even before explicit transactions. Okay, next is Neptune, which has transaction support scope, which is graph operations across nodes / edges within a transaction on a primary database or table. So keynotes: read replicas are eventually consistent. Transactions follow standard graph semantics. So this is very specific to the graph technology and how the data is stored. Next one is time stream, and the transaction support scope is single write operations. Batch writes also possible. And some keynotes: it is designed for high volume time series ingestion and analytics, not transactional consistency in the ACID sense. Then comes Elasticache, and transaction support scope is atomic command execution for multi-exec for Redis and Valkey. So these are some facts which I want to just bring in. Some keynotes: it's primarily a cache. Consistency depends on the engine and topology. Redis multi-exec groups command, Redis multi/exec groups command, but is not full ACID compliance. Next one, Amazon MemoryDB. So transaction support scope is atomic command execution, and same a multi/exec for Redis and Valkey. Some keynotes: it provides strong consistency on primary reads and writes. Durability is achieved via distributed transaction log, because it's in memory, so there will be transaction log, and that's how the durability will be achieved. Next one, QLDB. So it's a multi-statement, multi-document within a transaction. It offers the highest isolation level, serializable, immutability, and verifications are its key features or core strength. Next parameter is availability, service level agreement, and what is the target. So first one, RDS, it has a target of 99.95% of service level agreement across multiple availability zones. Next, Aurora, it has got even higher availability SLA target, which is 99.9 for multi-AZ and 99.99% for global database. Next one, Amazon Redshift. It is not explicit, but it depends focus on durability and recovery. So there is no because you can have managed database. It's like you can spin up nodes and all. So it depends on how you architect it. Next one, DynamoDB. So this is serverless, so they can give these numbers. So the target SLA is 99.9% for standard, and if you opt for global tables, it will be 99.9959%. Then key spaces is 99.99%. Document DB is 99.9%. Amazon Neptune is 99.99%. Time stream, it has there are two mode or two flavors, which are live analytics and influx DB. So live analytics is 99.9% and influx is 99.9. So live analytics is a bit higher. Then comes Amazon Elasticache, which has 99.99% for serverless multi-easy modes. Amazon MemoryDB has got 99.99% for multi-easy and 99.999% for multi-region. Amazon QLDB, it has 99.99% availability. Next one is management model and operational overhead. So first one, Amazon RDS, it's a fully managed and operational overhead is medium. Amazon Aurora, so there are few modes like fully managed, which is a provision mode, serverless, and there is a limitless distributed SQL. Operational overhead will be medium for provisioned, and if you opt for serverless, it will be low operational overhead. Redshift is a fully managed provision mode and there is a serverless mode. So there are two options. And same, medium for provisioned and low operational overhead for serverless. Amazon DynamoDB, so it is totally serverless. It has low operational overhead. Amazon Keyspaces, totally serverless. It has low operational overhead. Amazon DocumentDB, fully managed for instance based, or you have elastic clusters. Operational overhead is medium. Amazon Neptune, you have two modes. You can go for fully managed provision mode or serverless. So same, medium for provision mode and low operational overhead for serverless mode. Amazon TimeStream, so you have serverless for live analytics and fully managed for InfluxDB. So as I talked about, there are two flavors, and serverless is low and fully managed will be medium operational overhead. Amazon Elasticache will be fully managed, which is nodes based, and you can go for serverless as well. So again, medium operational overhead for low for fully managed and low for serverless. Then comes MemoryDB, and it's a fully managed model and it has a medium operational overhead. Amazon QLDB will be serverless management model and low for the operational overhead. Then now lastly, we have exam focused decision guide. So this will some statement you will see in the exam or some keywords. So you have to choose which one is the best. So scenario, if they ask for lowest latency caching, which is within microseconds, you have two options: Elasticache first and MemoryDB second. Elasticache go if you have like best for pure caching, potentially lower cost and supports memcached. Secondary option is MemoryDB. It provides durability via transaction log, strong consistency on primary nodes, and suitable as primary DB. And relevant snippets and some updates like Valkey support and pricing and multi-region global availability. So just to distinguish between which one to go, if they ask for this, they need some kind of durability and strong consistency or something, then go for this. But if you want pure caching solution and something like memcached, you will go for this one. Next one, if the scenario or the decision point is durable in memory database and primary storage should be used as a primary store, then you can, the key service that you have to choose for is MemoryDB, and it offers Redis Valkey compatibility with multi-easy durability and strong consistency on primary. Used when cache data loss is unacceptable or using as a primary DB. So it is used as a primary DB in the sense it's a main database, not the secondary or the second database, and you cannot afford any kind of data loss. And some snippets or updates, it has Valkey support and pricing, same, and your multi-region global availability. Next one, if the scenario or the decision point is highest performance managed MySQL or PostgreSQL. So you have two services, Aurora and RDS. They will be competing each other. Aurora, this is generally higher throughput and lower latency, auto scaling storage, faster replicas, global database, serverless, limitless distributed SQL options, Then some key features of RDS is broader engine support. As I talked about, Oracle and SQL Server. It is simpler for basic needs, potentially lower cost for non-IO intensive, input-output intensive workloads. Some snippets or some notes. Aurora distributed SQL generally available. Aurora serverless scales to 0. And RDS for this one scales to 0 in the sense you can completely shut it down, in the sense you can make it 0 when you are not in using it. So it will not cost you anything when there is no operation or no transactions. And RDS support available for Oracle January version 2025. So if that is also required, anyway, anything Oracle, you have to go for RDS only. Next one, managed Oracle or SQL. So SQL Server, which is Microsoft products. So only one option, RDS. So RDS is the primary managed service for commercial engines like Oracle and SQL Server. RDS custom allows more operating system or database access if needed. So again, RDS for Oracle January 2025. Next one, if you want serverless, scalable key value document store. So one option you have to go for key value, in the sense there is only DynamoDB. So that is just remember. And some key differentiator or exam focus points are it is extremely scalable. This is a pay per request, on demand or provision capacity. This is a flexible schema. You have global tables and default eventual consistency. Some snippets or updates, on demand prices reduction, multi-region strong consistency, which is in preview, and there is a warm throughput. Next one, next scenario is managed MongoDB compatibility. So exam may have something like this application is dependent on MongoDB API or something. So if they talk about MongoDB, immediately your brain should light up with DocumentDB. So some key differentiator are it provides compatibility with MongoDB, all these APIs, the drivers, all the MongoDB drivers, and the tooling. Offers managed features like backup, scaling, high availability, and some snippets or some nodes. It supports ACID transactions, and you have elastic clusters for write scaling. Next one, managed Cassandra compatibility. So if they talk about something like it has to work with Cassandra compatible APIs or applications or migration or legacy something, immediately key spaces is the right answer. It is serverless. It is managed alternative to self-hosting Cassandra. It will use the similar SQL API. You have on demand or provision capacity. It has got multi-region replication generally available in more regions now. Next one, if you have to model complex relationships, so the key service to be used is Neptune. So this is graph data model. So it will very clearly or very elegantly it will model complex relationships. So some key differentiator and exam focus points are it is purpose built graph database, and it supports Gremlin API, OpenCipher, and SparkQL. So these are the three very typical or standard format or the technologies being used for graph databases. It is optimized for traversing relationships, and there is a serverless option also available. And I talked about the SLA target already. Next, analyzing large graphs for overlap. So online analytical processing. So there is a Neptune have one flavor like Neptune Analytics. So this is a in-memory engine for fast analytics on large graphs with billions of edges. So it will use OpenCipher and built-in algorithms. It can load from S3 and NeptuneDB. And some nodes are Parquet CSV import export option available. Next one, we have high volume time series data. So time series in the sense there will be always a timestamp which will be the key differentiator in the so basically in IoT and all, timestamp is always being generated. So you have to use time stream because it is purpose built for time series. You have live analytics, which is serverless, SQL, and tiered storage, or InfluxDB, which is a managed open source. So yes, so InfluxDB is an open source product which is being offered via time stream service. Then it has optimized ingestion and querying. Next, if you want to have something like immutable verifiable ledger, then only one QLDB, and it provides a cryptographically verifiable append-only journal for tracking data history, centralized trust model. So this is still available, but for new customers, there are some other technology or service being offered, but this may show up in exam sometimes. Next, we have some database migration strategy. Then there are few services like database migration service. You have schema conversion tool, SCT tool from AWS, and there are some native tools. So you have homogeneous, like same database to database. You have simpler, which is simpler of often native tools or DMS work well. So it will work homogeneous as well as heterogeneous. So heterogeneous for complex, like one database engine to another. And this requires schema or code conversion, where schema conversion tool SCT will be used. And database migration DMS facilitates data movement. So you have to consider downtime like online versus offline or hybrid. Then some disaster recovery scenarios or decision point, and this is across cross region. So some key services that are involved are, so basically two regions, let's say one US and one Europe. So that kind of a situation. And you have, so now we will have the global databases. So we have Aurora, Neptune, we have global tables in DynamoDB, we have global data stored in Elasticache, we have multi-region replication through key spaces and MemoryDB, then cross-region read replicas and snapshot, which is offered in RDS. So a global database, in the sense this are truly global databases or global data stores. And as you go down, you will see there like it is achieved through some other like region read replicas and snapshots. So, but this, as if you read from top, it will be like truly global. And some key differentiator or exam focus points. The choice depends on the recovery time objective or recovery point objective, need for active writes, consistency requirements, and the cost. Global options offer lowest RTO RPO but may have higher cost or complexity. And some snippets or notes, MemoryDB multi-region now globally generally available. So this is also one of the contender. But in the exam, most of the time you will see global tables from DynamoDB and Aurora global database and global data store from Elasticache being, so there will be some scenario where they will say, okay, which one to choose. And if you know these three have this option, then you can easily choose. Otherwise, they will try to distract you into setting up through some other channels like set up S3 and do cross-region replication and load the data and some kind of thing like that. Next one, cost optimization. So you have reserved instances and savings plans, serverless, right sizing, IO optimized, data tiering, and time to live. So these are some things which you have to consider. Some key differentiator or exam focus points are match pricing model. So you have some options like on-demand provision, serverless to workload predictability, and use commitment discounts for steady state. Leverage features like Aurora IO optimized or DynamoDB standard. IA where applicable. So IA is infrequently accessed. Next one, security and compliance. So some key services being used is, so this is apart from the database. So you have encryption, which is provided via KMS, key management service, and TDE auth via IAM native, and then network security will be through VPC or private link, and all the other certification like HIPAA, PCI, SOC, and FedRAMP. And some differentiator or the exam focus point, verify service supports required encryption methods, authentication integration, whether it holds necessary compliance attestation via AWS artifact. So this service will give all the certification which is shared for all the database services. And you have to remember the shared responsibility model. So it is like AWS will take care of all the hardware and all, but customer will be responsible for managing security when they are using the product, like how to manage or secure their data, actual data. And that's all. Thanks for watching.